Alright, good morning, first period. This is Algebra 2, and this is your first day of Lesson 1A, and we are graphing linear equations today. So you may remember from Algebra 1, y equals mx plus b. This is slope-intercept form. M is your slope, that's your rise over your run, and b is your y-intercept, which is where we begin our graph. So M is the slope, and B is where you begin. It's your y-intercept. Okay, so we are graphing lines, which means you're going to need a straight edge. So you're going to need a ruler today. So you're going to want to grab a ruler. There are rulers over by my growth mindset bulletin board. They're in that blue container. You can help yourself. Otherwise, if you want to use a credit card or your ID or your planner, those make good straight edges. So getting started here today, we're going to start with the special cases, which is when you have just a y or just an x. Okay, so looking at number 1, we just have y equals 4, or 4 equals y. If you want, you can write that as y equals 4. And this is actually in slope-intercept form. It just doesn't look like it's in slope-intercept form. So I could rewrite this as y equals 0x plus 4. And now it does look like slope-intercept form. Our slope is 0, and our y-intercept is 4. But anytime you just have y equal to a number, this is always a horizontal or a side-to-side line. And so I'm going to go up on my y-axis, so that's going up to where y is 4. And the common mistake is just to put a point at 4, but we need to draw a horizontal line that goes through the y-axis at 4. So I'm going to draw a straight line that goes through y equals 4. And it needs to be straight, and it needs to have arrows. Alright, so here is our line for y equals 4. But notice the directions also say state the domain and range. So down below here, I'm going to go ahead and write domain and range. So I have domain and range. And sometimes you'll see me just write a D and an R. That's fine too. You can actually just write a D and an R. But remember, domain refers to your x values from left to right, and range refers to your y values up and down. So we're going to think about this as reading a book from left to right. And I'm looking, does the line continue forever to the left? Yes, it does. Does the line continue forever to the right? Yes, it does. So left and right is your x, that's your domain. And we're going to put negative infinity to positive infinity, because the domain and range go forever to the left and forever to the right. Now, as I go up and down, I'm going to go from the bottom to the top, and I don't have any y values at all until I get to y is 4. And 4 is the only y value, and that's what makes this a special case. So we're going to do a hard bracket because the 4 is a point on the line. So we have that square bracket or hard bracket with only 4 for the range because the only y value is 4. Right, so number 1 is done. We've graphed it and we've stated the domain and range. Looking at number 2, it's easy to miss this negative in front of the x, but remember the variable can't have a negative in front of it. And so we can put a 1 here and divide by a negative 1. And that way we have negative 1 is equal to x. Or if you prefer, you can write x equals negative 1. Alright, so this is the case where you only have x in a number. And so when you have just x in a number, that is a vertical line. And a vertical line has an undefined slope. Okay, so it's not a zero slope. Over here, this is a zero slope, just a flat line. An undefined slope is up and down. And so we're going to go on the x-axis now to a negative 1 and put a point. And now you need to remember to draw a vertical line. So the line is going to go up and down. And again, make sure you use a straight edge. You want your line to cover the entire grid, and that your line has arrows on both sides. All right, now this time when I look at my graph from left to right for my domain, and I'm just going to write a D for domain this time. As I go left to right, the only x value is what they gave us. X is a negative 1. There are no other x values where I have any graph. And so my domain is the hard bracket, negative 1. Only the x values here. Remember, domain is your x values. The only x value we have is negative 1. The range, however, if we go from the bottom to the top, is negative infinity to positive infinity. Right? So your special cases for domain and range are if you have a side-to-side, a horizontal line, or if you have an up and down, a vertical line. So this looks like the first page of your homework. The second page of your homework, they're going to tell you what the x-intercept is and what the y-intercept is. So they're telling you the graph will cross the x-axis, and for number 3, it crosses the x-axis at -5, so I'm going to put a point at -5. And it tells me it crosses the y-axis, the y-intercept is a -4. And so on my y-axis, I put a point down 4. You should know from geometry that any 2 points can make a line, and so from here I can connect these 2 points to make a straight line. Alright, and most lines look similar to number 3. They either have a positive slope or a negative slope, and number 3 here has a negative slope because as I go from left to right, it's like I would be going down a slide. And so I have a negative slope. So this is not the case where you have a 0 slope or an undefined slope like 1 and 2, which are your special cases. This is your normal, typical line. It's a line with either a positive slope or a negative slope. And most lines have a domain and range that is both negative infinity to infinity. And so anytime you have a line with either a positive slope or a negative slope, it's going to keep going to the left, and it is going up and to the left, but it's going to keep going left forever, and it's going to keep going right forever. Even though it's going down and to the right, it's still going right forever, and so that makes your domain, or your x values, negative infinity to infinity. And again, because this line has a negative slope, it is going to continue going up, and it is going to continue going down, even though it's going up and to the left and down and to the right, and so your range is negative infinity to infinity. So using that same idea, number 4, you should be able to do this one on your own. See if you can do this on your own, and then look up and see if you have the same thing as what's up on the screen right now. So Mrs. Powell, you may need to pause this for just a second so the students have a chance to do this on their own. But go ahead and see if you can do number 4 on your own. Right, so you should have a line that has arrows. It should be a straight line. It crosses the x-axis at -2. It crosses the y-axis at -3. You connect those 2 points, and the domain and range are both negative infinity to infinity. When you're ready, flip your notes over to the back side. Right, on the back side, this looks like page 3 of your homework. And the first 2 lines are in slope-intercept form, and page 3 of your homework is slope-intercept form. So remember, slope-intercept form is y equals mx plus b. And again, m is the slope, and b is the y-intercept. So if I'm looking at number 5, it's solve for y. It's y equals 3/5 x minus 1. So my m is what's in front of the x. It's positive 3/5. And we want to leave that in fraction form. And the b is a -1. And remember, b is where you begin. And we always begin on the y-axis. And every year I have students that start on the wrong axis. That's a really common mistake. You want to make sure you start down 1 and not left 1. So we're going to start down at -1. And then the slope is rise over run. And so it's not like when you graph a point. If we were graphing the ordered pair 3, 5, you would go right 3 and up 5. That would be right 3 and up 5. But remember, when we do slope, you go up and down first, and we're going to go up because it's a positive 3, and then to the right because it's a positive 5. And so we're doing rise over run, which is the opposite of graphing an ordered pair. So instead of going right 3 and up 5, we're going up 3 and right 5. That's different. So make sure you're doing up and down first and side to side second. So here we go. 1, 2, 3, and over 1, 2, 3, 4, 5. There's my first point. You can connect those 2 points. Any 2 points will make a line. Or if you like, you could also do the opposite and go down. So I'm going to go down 1, 2, 3, and to the left 1, 2, 3, 4, 5. And that is still a point on the line. It still connects the other 2 points. It just makes it so it's a little easier to fill up my whole grid accurately. And even though I did it with a ruler, I still had a little slip of my pen. So make sure you're using a straight edge. It's easy to make a mistake without a straight edge. It doesn't look quite right. There we go. And again, my graph goes forever to the left and forever to the right, so your domain is negative infinity to positive infinity. That's all real numbers. And the range is also negative infinity to positive infinity. And I want you to use this notation. Don't use the R symbol for all real numbers. You need to be able to do the domain and range using interval notation with the infinity symbols. And if it's hard for you to draw an infinity symbol, just make a sideways 8. All right, if you look at number 6, it's also in slope-intercept form, and I chose number 6 because the 2 is not a fraction. So our slope is 2, but remember you can write any number over 1, so if it's not already a fraction, just write the number over 1. That's going to be our rise. We're going to go up 2 and to the right 1. And the b, where we begin, is 1, but make sure you start on the y-axis and not on the x-axis. So we're starting up at 1, not right 1. So there's our starting point, and our slope is to go up 2 and to the right 1. All right, and again, you could go down 2 and left 1. I'm just going to go ahead and connect my points. There's my line. I've got a straight edge. It has arrows. And my domain, again, is negative infinity to infinity. It's always going to be negative infinity to infinity if your line has a positive slope or a negative slope. And then the range is also negative infinity to infinity, which is also always the case as long as you have a positive slope and a negative slope. So just looking at our equations, our slope was a positive 2, and our slope was 3/5, and so those are both lines with a positive slope. If we go back and look at the warm-up again, I guess it wasn't the warm-up, just the first 2 examples. Here, this was not slope-intercept form because it was just a y, and this was not slope-intercept form because it was just an x. And so remember, this was your 0 slope, not positive or negative, but 0, and this was your undefined slope. All right, the last 2 are not in slope-intercept form. These require a little bit of work, and your goal is to get the y by itself. And so if I look at number 7 here, the y is almost alone, but it's negative 2 times y, and so to get the y by itself, normally we would just go ahead and say divide by negative 2 to all 3 things. And some of you might be able to do that math, but some of you might get stuck with a fraction of a fraction. So we're going to have y equals. Now some of you could say, well, negative 1/2 divided by negative 2, a negative divided by a negative is a positive. And some of you might know half of a half is a fourth. And if you know that, you can go ahead and write 1/4 x. And then negative 8 divided by negative 2, that's not so bad, that's just 4. But if you didn't know how to deal with the half of a half, remember dividing by 2 is the same thing as multiplying by 1/2. And so when we have this negative 1/2 divided by negative 2, negative 1/2 being divided by negative 2 is the same thing as negative 1/2 times negative 1/2. And then it's easier to see where that positive 1/4 comes from. So our slope is 1/4, that's your m. Your b is a positive 4, so we're starting up at positive 4 on the y-axis. And our slope is to go up 1 and to the right 4. And you're always going to go up and to the right or down and to the up and to the right or down and to the right. And we'll look at a negative slope here in a minute. And then if you want more points, then you can just do the opposite and go down 1 and left 4. But make sure you're going up and to the right or down and to the right so that you have the correct slope, the positive slope or the negative slope. All right, we're just about done. Our domain and range, again, are negative infinity to infinity for both of them. And on your homework, don't forget to do your domain and range as well. Oh, you can't see that, can you? There we go. Our last example is number 8, and on number 8, we need to get the y by itself. And because there's not a lot of room, I'm going to do number 8 off to the right here where there's a little more space. So I'm just going to go ahead and rewrite negative 4 is equal to negative 2y minus 3x. And so to get the y by itself, we're going to add the 3x. Now, negative 4 and 3x are not like terms. And so I have 3x minus 4 is equal to a negative 2y. And I'm going to go ahead and divide by negative 2. Right, so this time we end up with a negative slope. We have y is equal to, we have a negative 3/2, and it doesn't matter if you put the negative on top or bottom, but don't put it in both, otherwise it would turn positive. And negative 4 divided by negative 2 is positive 2. Now it's in slope-intercept form. So we're going to go up, our b is 2, so we're going to go up to 2. And this time our slope is negative, and so we're going down, but still to the right. Down 3, and to the right 2. Down 3, and to the right 2. And again, the domain and range are both negative infinity to positive infinity. Okay, it is a line with a negative slope, and so we have our line, and we're done.